Hello students, welcome to mathematics class. Students, this is part 24 of the chapter squares and square roots. In this part 24, we will continue solving questions from the exercise 6.4. In our previous session, we solved up to the question number 5. So we will continue from the question number 6. Students, in question number 6, find the length of the side of a square whose area is 441 meter square. So here, while solving this question, write the given area of the square, 441 meter square. To find the length, of the side of a square we need to find root 140, 441. Since s square equals to 441, where s is the side of a square, it implies s equals to root 441 you have to find. You know how to find this? It is 21 meters. So write the conclusion. Therefore, the length of the side of a square is 21 meters. So this is how we do solve this question. It's easy one. Main thing is you have to write in working steps. Question number 7. Question number 7 has got two sub questions. In that, first sub question is, if AB is of 6 centimeter, BC of 8 centimeter, find the length of AC, where ABC is a right angled at B. So if you consider a right angled triangle, right angled at B, then we need to recollect one of the important property called Pythagoras property. So Pythagoras property tells square of the hypotenuse is equal to the sum of the squares of other two sides. So side 1 and side 2. Here always hypotenuse is the side opposite to the right angle. So by Pythagoras theorem, here length of AC square is equals to the length of the AB square added to the length of BC square. So the moment we get this relation, substituting the values of AB and BC, 6 square plus 8 square, which gives 36 plus 64. It implies 100 is the AC square. Now, therefore, AC is equal to root under 100, which is 10. So, therefore, length of the AC is 10 centimeter. Write the conclusion. So, this is how we solve the question number 7. So, the other sub question, use the same knowledge, substitute the values and find the length of AB, whereas AB is here. So, BC square to be sent that side. It becomes AC square minus BC square is equal to AB square. So, by substituting the values of AC and BC, you can find the AB square. I hope you will do the second sub question B. Now, let us see the question number 8. Question number 8 is, a gardener has 1000 plants. He wants to plant these in such a way that the number of rows and the number of columns remain same. Find the minimum number of plants he needs more for this. How many extra he needed? A minimum number of plants that he needed, so that he has condition of number of rows and number of columns same. So, to solve this, we will go for first assuming. Let us assume that the number of rows be x. Therefore, from the condition, therefore, the number of columns will be x. So, with the condition of this, number of rows and number of columns are same. Therefore, total number of trees will be x into x. It implies x square. But here 1000 is not a perfect square. So, we need to make this 1000 as a perfect square. How can we make this 1000 as a perfect square? By adding some number or by subtracting some number. So, therefore, as the given number of trees thousand is not a perfect square, we need to find the least number that to be added. So, to make it perfect square, So we'll continue in the next page. Here, to find that, you will go for long division method. You know how to find long division method. Okay, let me take here properly. A line is drawn. 1000 is written in such a way that from units and pairs are made. 3 is a 9, so 1 is the difference. 3 added here gives 6. We need to identify a number having tens place as 6 and units place to be guessed, so that the same digit comes here in quotient. So we will bring down the other pair, whereby bringing 0 0 the down, it becomes remainder as 100. Now obviously 1 is a suitable one. 61 ones are 61. So now 100 minus 61 is 39. So this is the excess in 1000. Therefore 1000 lies between 32 square and 31 square. So who is that minimum number? Minimum number that to be added to make 1000 a perfect square is 32 square minus 1000. What is 32 square? 32 square you need to find out. It is 1024 minus 1000, that implies you need 24 more. Therefore gardener need 24 more plants. So this is how you can conclude. So this is the end of the question number 8. Now let us take question number 9. Now let us solve the question number 9. Here in this question number 9, we have, there are 500 children in a school for PT drill. They have to stand in such a manner that the number of rows is equal to number of columns. How many children would be left out in this arrangement? Here it is similar to the previous question number 8, whereas there we found what is to be added. Here we have to calculate how much is left out, means how much is to be subtracted. You write the working steps as I have done in the case of question number 8. For this question number 9, you have to write on your own the working steps. Let me do only the important calculations. Here children, 500 I am writing by making pairs. It becomes 0 5 as the leftmost pair and next pair is 0 0. Now 2 2s are 4. 5 minus 4 gives 1. Here adding 2 in the below gives 4 in the tens place, and I need to identify the units place digit which suits and gives the next digit of square root of a number. By bringing this next pair, remainder becomes 100. Now I have to find by trial and error method this suitable digit. Obviously it is 2. So 42 2s are 84, which means it gives 16 as the difference. Therefore I can say this 500 is more than 22 square but less than the 23 square, whereas 22 square is 484. That means out of 500 students, the number of children, therefore the number of children that would be left out in the arrangement is 16. So these are the people who do not have the chance of standing in a PT drill, so they are left out. This is how we solve this question. So with this we have completed exercise 6.4 and we have completed this chapter, squares and square roots chapter. So let us see what we have discussed in this chapter. Students, in this chapter, if a natural number m can be expressed as n square, where n is a natural number, then m is square number because m is equals to n square. M is called square number, or it is called in simple way square of the number n. All square numbers end with 0, 1, 4, 5, 6 or 9 at units place. So no square numbers end in 2, 3, 7 or 8. This is what we learned. Square numbers can only have even number of zeros at the end. So no square number ends in odd number of zeros, we have learned. Square root is the inverse operation of square. That is, we say here number n as the square root of the number m. Here n is called square root of the number m. There are two integral square roots of a perfect square. Positive square root of a number is denoted by the symbol this radical sign. For example, 3 square equals to 9 gives root 9 as 3 only. Though there is a possibility of getting minus 3, but we have to keep before this sign only plus or minus. We have learnt these things in this chapter. So from our next class onwards, we will discuss exemplar problems of this chapter, squares and square roots. So till then, take care, and with this I will wind up this session. Jai Hind. Thank you.